Grand Cade. Grand Cade. Grand Cade. Grand Cade.
Hi there! What is the difference between a physical and a chemical change? Well, you see, during a physical change, the molecules in a substance speed up or slow down to break away from their attractions. This can cause them to change state of matter, like going from a gas to a liquid or a solid to a liquid. During a chemical change, however, the atoms in the molecules break their old bonds, rearrange themselves, and form new bonds with other atoms to create different products.
Condensation is an example of a physical change that demonstrates a gas changing to a liquid. When I have a cup of hot water and put a clear cup on top of it along with some ice, we can see that the water has then been condensed on the inside of the cup. But why does this happen? Let's break it down. H2O is water. Water is in the gaseous state when it's considered water vapor. The gaseous state of water inside of the cup from the evaporation is attracted to the cold water molecules outside of the cup. So they connect to the cup and change into the normal water form of H2O.
Evaporation is the process of a liquid turning into a gas. This happens when the atoms in the liquid get heated up, which causes them to move faster. They move fast enough where their attractions for one another are so low they break their bonds and become a gas.
Melting is an example of a physical change. When I have this marshmallow and then I heat it up, it gets all gooey on the inside. That happens due to the heating up the sugar molecules within the marshmallow, which causes them to move faster and vibrate faster, which increases the energy, which allows more molecules in the marshmallow to move more freely and spread apart, which causes the gooiness.
To demonstrate evaporation, we're going to take 2 jars and fill them with the same amount of water. Then we're going to put 1 jar in a cold spot like a fridge, and we're going to put 1 in a warmer spot like a windowsill. So when water is evaporated, the molecules have to speed up enough to be able to break away from their attractions. Because the molecules move slower when they are cooled down, the molecules of the water in the fridge are moving a lot slower than the water on the windowsill. This causes the molecules that are in the water in the fridge to take longer to break their attractions. At the 2 jars, a couple days later, we can see that the water that was on the windowsill, the level is a lot lower than the water that was in the fridge. So heating up a substance can significantly increase the rate of evaporation. Have you heard about the guy that evaporated?
No.
He shall be missed.
Fire is a representation of a chemical change. Whether it may be the match striking the matchbox or the fire that results, both have chemical changes. The fire has many properties required to burn, and the resulting chemical is carbon dioxide, CO2, and water vapor, H2O. These are coming from the combustible materials in the match, and the oxygen in the air, O2, as fuel.
A chemical change is baking soda and vinegar. When I pour the vinegar into the bottle and then pour the baking soda into the balloon, then when you put the balloon over the bottle, what happens on a molecule level is the acid in the vinegar reacts to the sodium in the baking soda, which then causes the production carbon dioxide gas from the bases reacting with each other.
To demonstrate a chemical change, we're going to need a cup filled with enough vinegar to fully submerge just a regular egg. And then we can place the egg into our cup, and we're going to let this sit for about 1 day. And the reactants in this experiment are calcium carbonate in the eggshell and the vinegar. So the atoms that make up the calcium carbonate molecules and the vinegar break their old bonds with the other atoms and rearrange themselves, which will cause new molecular bonds. So the products in this experiment then, the reactants of the calcium carbonate and the vinegar will form the product, which is calcium acetate, water, and carbon dioxide. If you look at our egg here that has been sitting in the vinegar for about 24 hours, we can see that the shell has completely dissolved, and we're left with a membrane around it, which can cause the egg to be bouncy, unlike a regular egg with a shell. So this is because the atoms in the calcium carbonate will break their old bonds and form new bonds with the atoms in the vinegar, which will cause the eggshell to dissolve. And this is what makes it bouncy. In a chemical change, the atoms will break their old bonds and form new bonds, creating a new substance or a product, whereas a physical change will speed up or slow down the molecules in a substance so they can break away from their attractions to become a different state of matter while still being the same substance. So it's pretty excellent, wasn't it? Get it? Because it's an egg.
First, grab hydrogen peroxide. Then grab dishwasher soap. And when you combine them together and shake it up, it will result in some foam forming. Also, the reactants in this experiment are hydrogen peroxide and dishwasher soap. In these reactants, atoms break their bonds and form new ones, causing it to release a product, oxygen, causing it to foam up.
Funny stuff, I know. Enough. We need to put a spoon, 4.5 of baking soda. Should be good. Vinegar. Just a bit, a little bit of vinegar. And then you can put your food coloring, some drops to there. Wow, just ruined it. Unbelievable. You can mix around your baking soda. That's fine. Okay, mix it there. Then I'm gonna put this in there. Take a stir around a bit. Sure. So you can see the bubbles rising. Realize this happens because the vinegar and the baking soda collide with each other, or there are two reactants to form a chemical reaction, which then releases carbon dioxide, which you can see the bubbles, which take the food coloring and rise up as all the carbon dioxide gets released into the air. Easy. Carbon dioxide is a product of the reactants. And then, yeah, homemade lava lamp. Woo, looks disgusting, but whatever.